Well, good evening, everyone. Thank you very much for coming out in the cold weather on a Friday night to hear me talk, because I'm nobody special, but my name is Kelley Miller. I am a member of the Texas Astronomical Society, but I am also a solar system ambassador for NASA's Jet Propulsion Laboratory, and which is a volunteer role, so I want to make sure that I make everybody understand that I'm not an employee of NASA. I don't work for JPL. I'm just a volunteer, very enthusiastic volunteer, and so I don't know the ins and outs of their missions like they do, the engineers do, but hopefully you'll get a really good idea of the Curiosity rover and Mars a little bit. And Bradford, who usually teaches this class, told me that some people had requested, they wanted to learn about this mission, so he asked me if I would do a talk, and so, are you the guilty party? And so here I am, and so there's a lot to talk about. So Curiosity's been on Mars for several months now, and so there's a lot to cover. Just wave me down if I'm talking too fast, because I get really excited, and but we'll go ahead and get started here. By the way, this picture that's up here, there's another one version of it later in the presentation. This is a self-portrait that Curiosity took back in November. And if you go to their website, which, by the way, I have some information on the rover up here, and the website is listed there. I will also have it several times in the presentation. So the website for this mission is excellent. The videos, you can get raw images. It's fantastic. I spent hours just looking at different stuff. And but there's a video that they put out that shows how Curiosity did this self-portrait. So it's very interesting. All right. So, oh, it's dark. So this is a beginning astronomy class, and so I wanted to make sure that we talked a little bit about Mars, the planet, which is the fourth rock from the sun, and talk a little bit about the planet itself. So it is a small planet. It is the second smallest planet in the solar system, and it's about half the diameter of Earth. And it looks reddish because the minerals on the surface of the planet are made out of iron-rich minerals. And so you think about iron, when it rusts, it turns red. Mars has two moons, Phobos and Deimos, and they, if you ever see pictures of the moons, they look like potatoes. They're not round like normal, moons would look, because there's not enough gravity to make the moons spherical. So they look like potatoes, and the theory is that they might have been asteroids that were captured by Mars. Mars has the largest volcanic mountain in the solar system, which is Olympus Mons. It's something like 3 times the height of Mount Everest, so it's a big mountain. Gravity is about 38% of ours, so we were having a conversation about this today at work. We were talking about, I would love to go to Mars because that means I would weigh a lot less. The only thing is, it does not mean that I would be able to wear a smaller pair of pants. So, interesting. Mars has very little atmosphere. A day on Mars is very close to ours, just about 40 minutes longer, 24.623 hours, and they call a day on Mars a sol. A year is 1.88 Earth years, so it takes almost 2 Earth years to make one orbit around the sun. Temperature swings from minus 225 degrees all the way as high as 95 degrees. 95 degrees Fahrenheit was recorded by Spirit, which is one of the little rovers that's no longer with us, but still up there, and it did record that high of a temperature. That's not an average temperature, and that was also on the equator. The minus 225 is near the polar caps. So big temperature swings. Average distance to the sun is about 141 million miles. What else? At one time, we do know that Mars had a lot of water on its surface, and it has very similar to Earth. It has a lot of impact craters. It has volcanoes, valleys, deserts, and the polar caps. It also has its rotational axis is tilted just like Earth's, and so it has seasons just like Earth. So now, Curiosity launched on November the 26th of 2011 from Kennedy Space Center in Florida. And it has several scientific goals. The first one is they want to determine if the landing site, if its habitability includes, including the role of water. The landing site is called Gale Crater. They spent a number of years researching where they wanted to go, and they're very excited so far about what they've seen already. There's still a long ways to go. They want to study the climate and geology of Mars, preparation for a future manned mission to Mars, and there are a total of 10 instruments on the rover. Now, before we send a human to Mars, well, accepting the mission that was announced this week by a private billionaire, if we ever do a manned mission where we actually land on Mars, before we do that, most likely we will do some kind of a sample return mission where we will send a rover or a lander or something to gather some samples and bring those back to Earth, which will be a good test to see how we do. So the primary mission is 1 Martian year, which is about 98 weeks, or approximately 2 Earth years. Now, that's what, for the little rovers, Spirit and Opportunity, their mission life was 90 days. And we're now going into 10 years for those missions. So we could extend this one as well. This is the website that I was telling you about. It is listed on the back of the big picture of Curiosity. And again, it's a terrific website. So there are 10 science instruments on, I don't know if I brought my laser, but I don't know what to do with it. There's 10 science instruments on board Curiosity. I did want to mention that this rover weighs almost 2,000 pounds. It has about 165 pounds just in instruments. The little rover, Spirit and Opportunity, in total only weigh 384 pounds. So you can see the difference. Curiosity is about 7 feet tall, about 9 feet wide, and almost 10 feet long. So think of a small, like an SUV, only a little bit taller. And I do have a 3D image of it and some 3D glasses that you can take a look at a little bit later. It gives you a really good perspective. This was when it was in the clean room. One of the things, I'm going to look briefly at all of the instruments, but I wanted to point out this right back here. That is the power for the rover. All of the previous, like the Phoenix lander, the Spirit and Opportunity, they use solar arrays to get power. The problem with that is that there's lots of dust. And when the solar arrays get dust on them, it causes problems. And this rover needs a lot of power to run all these instruments. And so they chose a nuclear route. So this has nuclear power. And it's actually, Joe, it's very similar to the one going to Pluto that we learned about last week. It is a really terrific generator, is what Dr. Stern called it. But it does have, it's a nuclear generator. What else did I want to do? Oh, it has the wheels, has 6 wheels. The wheels are about 20 inches in diameter. The arm itself is 7 feet long. The turret that's down here at the bottom weighs about 75 pounds, so it's a good size rover. So let's look at the instruments very quickly. The one up at the top is called the ChemCam. The ChemCam is a laser with a spectrometer in it, and it also has a high definition camera in it. Actually, there are a total of 17 cameras. Several of which are high definition. They can, for the first time on Mars, capture high definition video. So some pretty exciting stuff there. But what this instrument does is it shoots a laser at a rock, and the sparks that come off of the rock, they use the spectrometer that's in that instrument to look at the colors of the sparks to determine what kind of minerals might be in that rock, and then they decide if it might be something interesting. If it's not, then the rover keeps on moving. Now, the next, one of the most striking features is the eyes of the rover. There's actually 2 cameras here, and then there's 2 navigation cameras there. What do you notice about the 2 eyes?
Well, different apertures.
Right. Okay, so we have a wide zoom and a regular camera there. Okay. Then right below the mass cam that we were just looking at is the Rover Environmental Monitoring Station, or REMS. Of course, you know, with NASA there's lots of acronyms. But there are 2 booms that come off of the mast that measure wind speed and temperature, all kinds of things. Unfortunately, when the rover landed, they think due to vibration or something else, one of the booms got disconnected or something came loose and it's not working. However, the one that is working very well. It was actually able to detect a dust storm that was many, many miles away on Mars. So it's still working.
Were those 2 monitoring systems supposed to each be doing something different, or was it a redundancy?
Well, it's redundancy also, but they're facing different directions.
Ah.
Okay. So you got wind coming this way, or you got wind coming this way. And speaking of redundancy, all of the computer systems and everything else are redundant, just like they do on every spacecraft, which is a good thing, because just in the last day or so, they've had to switch to computer B because there was a memory problem with computer A. So while they're working out that issue, they had to switch all the software over to the other computer. So now we have 3 rock analyzers on the rover. One is called APXS, and just identifies the chemical elements in rocks. But your 2 primary instruments on board that are, this is what we're looking for, is the ChemCam and the SAM. ChemCam uses X-ray diffraction to identify and measure the abundances of minerals. SAM is probably the largest instrument on the rover, and it's looking for organics, which is the big part of this mission. They're looking for organics, things like carbon or things related to carbon or methane, so the building blocks of life. On the end of the rover's arm, there is a camera called the MALI, or the Mars Hand Lens Imager. It's like a magnifying glass with a light. So this is for the previous missions. They've had these cameras that can take close-up pictures, but they can't work when there's a shadow or at nighttime. This camera will be able to operate if there's a shadow caused by the sun or if it's at night. And this is the camera that they use for the self-portrait. So we can do some pretty neat stuff. Then there's 2 radiation detectors. We have the RAD and the DAN. And the RAD was actually used during the spacecraft's transit to Mars. Sometime, probably about 2 or 3 months after launch, there was a huge solar storm. And so they turned that instrument on so that they could see if they could detect radiation coming from that solar storm and what kind of effect it would have on the spacecraft. Even though the spacecraft was inside the protective shell, they wanted to see, and they were able to detect some stuff coming from that solar storm. It was pretty neat. The Mars Descent Imager, or MARDI, the camera on the left is actually on the bottom of the rover. And the picture on the right, we're going to watch the video in just a moment, the high definition video of this. But they recorded the entire descent down to Mars from the time that the heat shield comes off, which is what that piece is there, all the way until it made touchdown. And so we're going to look at that video in a minute. And the robotic arm that I mentioned earlier is about 7 feet long, and it has a whole bunch of instruments. You could think of it as a Swiss Army knife for the rover. It has a jackhammer drill and a rock brush, the camera that we were just looking at, the MALI, and what else does it have? A spectrometer, and so it has all kinds of tools. Of course, it's a turret, so it spins around and it can turn sideways. And so it's the workhorse of the rover. Now, the powder acquisition drill system. I was on a conference call with JPL. See the guy in the picture back there? That is Dr. Robert Anderson. He actually designed the drill system on the rover, and that's a picture of him testing it. They tested this thing, I don't know, thousands of times before they sent it up. But anyway, the whole conference call was just about the drill, because they were getting ready to drill for the first time, and it's fascinating stuff. What happens is, here's the drill. It's a jackhammer type drill that also rotates, and when it drills into the rock, the powder that comes from the rock goes up into the drill. It comes down this little thing here, and it goes into a scoop, and I'm going to show you pictures of the scoop in a minute. And then they take the scoop, they shake it, and so that they can get rid of some really large particles, and then the scoop takes it and puts it into the instruments, either the ChemCam or the SAM. Now, I circled the drill bit up there. Learned something very interesting. Don't say it if you know what it is. But they were trying to find a drill bit that would, hold up to what they needed to be able to do. They weren't sure, what the rock composition was going to be like. So they found these drill bits at Home Depot. They're Hilti drill bits. They tested them and tested them and tested them and said, wow, this is going to work great. But the problem was that they had such stringent cleanliness requirements, and the drill bits themselves had something on them, and they didn't want that contaminating, a substance from Earth contaminating the results that they got from the rock samples. And so they called up Hilti and they said, this is NASA. We're going to send your drill bits to Mars, and we would like to know if we can get the specs, the complete specs for these drill bits. They said no. So they sent the drill bits to the lab at JPL, and within 4 hours they had the complete specs and realized that the drill bits were covered in some kind of paraffin coating. And so they used an acid wash, and they were able to get all that stuff off. The rover has 3 drill bits, so if one breaks, they can just drop it. The rover can go to the storage area and get another one and be good to go. Because the drill is really going to be one of the big instruments to get the rock samples.
I can't believe Hilti said no.
Yeah, they said no. So anyway, NASA did call Hilti back and said, guess what? Your drill bits will work, and we didn't need your specs, by the way. All right, I'm a ham radio operator, and there's several of us that are. And so I found this very interesting. The wheels have these little cutouts in them that spell out JPL in Morse code. So if you look at the tracks for the wheels, it spells out JPL. I thought that was kind of cool. The wheel system is very interesting, by the way. They based it off of a rocker bogie system, which is kind of like what they have on trains. And so all of the wheels kind of move independently. I think they can actually release any of the 6 wheels. So if one gets stuck, and then they can keep on going. Because that's what happened to one of the rovers. It got stuck, and they couldn't go anywhere after that.
Yeah. That's how Spirit died, yeah.
Yeah.
They couldn't maneuver it to a hill to get sunlight during the wintertime, and it froze.
All right, so there were about, right now there's probably anywhere from like 200 or so JPL engineers, about 400 scientists around the world that are working on this mission. There were thousands and thousands of people around the world that actually worked on this mission. It took somewhere between 8 and 9 years to go from beginning to launch. And so in a moment I'm going to show you a couple of videos, and I want to tell you about a couple of very important people that, did anybody watch the landing, by the way? I stayed home on a Monday because it was in the middle of the night. The landing was at 12:30 in the morning, so I stayed at home so I could watch it. It was awesome. Anyway, if you watch the landing, then you will recognize these people because they became like rock stars after the landing. And So I'm going to tell you a little bit about those, but let's think back to like the Apollo era. Think of the mission control. What did those people look like? Those guys, those engineers. What do you think of? Suits, white shirts.
Yeah,
what else?
White shirts, black tie, glasses, pocket protectors.
Mm-hmm. Yep.
They're really adventurous. They might wear a boat.
Slide rule.
Slide rules.
Slide rule, yes.
Yeah. Saw a few of those on the table.
Times have changed, let me tell you.
Cigars,
Okay.
pipes,
The
cigarettes.
Well, I'm going to show you in a minute the landing sequence, which was just absolutely incredible. If you've ever seen the video of this thing. This guy that I'm going to show you, Adam Stelzner, the rock and roll engineer, he was the lead for the entire entry, landing, and descent and landing procedure. And he grew up in a very wealthy family out in California. He did terrible in school. He failed geography, and he just decided the school was not for him. So when he graduated from high school, he played drums and bass in a band, played in a rock band for a couple of years, and he was coming home from his gigs every night, and he noticed that Orion, the constellation, was never in the same place every night, and that just fascinated him. He wanted to know why. So he dropped out of his bands. He went to his local community college and decided to take an astronomy class. The only problem was that in order to take the astronomy class, he also had to take a physics class. And here he is, he's failed geography. His dad told him that the only thing he would ever be good at would be digging ditches. And so, anyway, he just excelled. He was so fascinated by all of this. He went on to get his PhD in engineering, and he's been at JPL for a long time. He's worked on the Galileo program, Cassini, and the Mars Pathfinder, and Spirit and Opportunity. He was responsible for the landing of those as well. And anyway, so it's pretty fascinating. And that was him at the end after they landed, his response. And then there's this guy, the Mohawk guy, Bobak Ferdowsi. I'm sure I'm mispronouncing his name. But for every mission like this, he has a hairdo. This is a Mohawk. Notice the gold stars cut into the side of his head. He's got pink and purple in his hair. He also attended the inauguration parade this year, and he was at the State of the Union address. He was sitting with Michelle Obama, and he had a special do for that as well. He had NASA painted in red, Mars painted in red on the side of his head. But anyway, this guy is pretty incredible too. He's an MIT, went to MIT, and he was the flight director for the landing of Curiosity. So some pretty big changes between the Apollo era and now, but still some really incredible smart guys. And I was going to read to you what, right after the landing occurred, President Obama called the Curiosity team to congratulate him, and he said, he made a note of the popularity of the Mohawk guy, and he said, "You guys are a little cooler than you used to be." He said, anyway, let's see, anything else? No, okay. Now, Clara Ball was a little girl. I think she was about 9 at the time, from Kansas. She beat out 9,000 applicants to name the rover. And she wrote an incredible essay, which I'm not going to read to you, but it wasn't very long, so you can go Google it and look at it. It's pretty neat. But she named the rover, and this is a picture of her just a day or two before the landing. She was actually there. She got to sign her name on the rover itself. She signed it in English as well as Chinese, I believe, and then she wrote Curiosity on there, which is pretty neat. Very sharp young lady. I think she's now 15 or 16. Okay, so this is the entry, descent, and landing, and I'll go through it very quickly. When it takes 7 minutes from the time that it hits Mars's atmosphere until it makes touchdown. And so up here, you have the cruise stage, separates from the back part, and when it makes entry interface, it starts decelerating. The parachute deploys, the heat shield comes off, and at the moment that the heat shield comes off is when the camera on the bottom, Marty, starts filming. They also have a radar on the bottom so that they can try to find a flat area to land the rover. Then the back shell separates from the rover, and I call it the jetpack, but it's the powered descent, and it just gently sets it down, and when it's about 60 feet off the ground, it lowers the rover down on tethers, 3 tethers, and sets it down and then flies away. And so in a moment when I show you the first video, they have an animation of that. I want to make sure you know that it's just an animation and not what actually happened. Then when we see the second video, you'll see the ground getting closer in the camera. And this sequence here was so crazy that Adam Stelzner, the first guy that I showed you, he had to make a trip to Washington, D.C. to explain to them why this was going to work. All the previous, like the Phoenix lander, Spirit and Opportunity, when they landed, they used this airbag thing where it just dropped to the ground and just kind of rolls. Well, when you have a 2,000-pound rover, you can't do that. This ain't going to work. This is an artist concept of what I call the jetpack, and you can see the 3 tethers. This was an umbilical cord that had all the electrical power and stuff, communications. So the peanuts, yeah, let me tell you about the peanuts. It's sort of a tradition with JPL. It started back during the Ranger program, which was a mission to the moon back in the 60s, or was it the 60s? Yeah, in the 1960s. And they weren't having very good luck. All the missions were failing, and somehow they just started eating peanuts and everything started going really well. So it's a tradition to have a canister of peanuts at all the missions in the mission control room. So,
yeah, scientists aren't superstitious at all.
No. They also have this marble thing too that was like Mars-colored marbles, and where they had a countdown to the landing day, and on the marbles they'd move from one jar to the other, something like that. Okay, so 7 minutes of terror. We're going to do a little easy math here. Let's say that and I should tell you that it takes, at the time, it takes 14 minutes for communication to reach from Mars back to Earth, okay? So let's say that the actual time that Curiosity enters the atmosphere is at 12:10. So if it takes 7 minutes to land, that means that the landing, the actual landing time is what?
12:17.
12:17. So now, the rover has entered Earth's atmosphere at 12:10. I said it takes 14 minutes for communication to reach Earth. So what time did we get confirmation that it had reached, or that it had entered the atmosphere?
12:24.
12:24. So take a look at that for just a minute.
Already on the ground.
Yep.
So then 7 minutes later, at 12:31, we're just finding out. So we had to wait a long time before we knew for sure that it had landed. So if you had worked on a mission for 8 or 9 years, and you're sitting in that mission control, what are you thinking? When you see the video in a minute, you'll see what Adam was thinking. So here again are some of the people. We already talked about 2 of them. Alan Chin is the narrator that you will hear in the video. Charles Bolden is the NASA administrator. You just get a quick glimpse of him, but he's sitting on the back row where all the VIPs, where the big bosses were sitting. Bill Nye, you'll see in the first video, he was at a Planet Fest nearby JPL, and so he was kind of shooting off some crowds. And then that's the first image from Mars. So if you were watching the landing, very shortly after it landed, they were able to get this first thumbnail. And it's a little grainy, but the reason that is that this camera had a dust cover on it. And so once they took the dust covers off, then you get much better pictures. So let's watch this first video.
Things are looking good. Coming up on entry.
And that's an animation.
Vehicle reports entry interface. At this time, we'll begin pressurizing the propulsion system to increase the thrust of the system. We'll use that for all the maneuvering in the atmosphere we're about to do. We're standing by for guided start of guided entry. Beginning to feel the atmosphere as we go in here. The vehicle's just reported via tone that it has started guided entry. At this time, the vehicle is beginning to steer its way to the target. We have seen peak deceleration. It is starting its first negative burst. It is reporting that we are seeing G's on the order of 11 to 12 Earth G's. Two is starting. We are now getting telemetry from Odyssey. We should have parachute deploy around Mach 1.7.
There's Charles Bolden.
Parachute is deployed. We are decelerating. Fuel has separated where we found the ground. We're down to 90 meters per second at an altitude of 6.5 kilometers ascending. Standing by for batch separation. We are in powered flight. We're at an altitude of 1 kilometer descending. Standing by for sky crane. Sky crane is started.
Eagle Dot, you remain strong.
Touchdown confirmed. Received.
That's Mount Sharp, that's back in the back. That's the destination for Curiosity. Okay. Now, I told you about the camera, the Marty camera that's underneath the rover. And so I'm going to show you this video. You'll hear some of the same audio, but all you're going to see is the camera and what it saw. And I want you to notice a couple of things. At this point, the parachute has deployed, and it's black at first, but then the heat shield comes off. And you're going to notice that the picture is kind of waving like this. And then as soon as you hear him say something about being in powered flight, you're going to see this jerk, and then it gets real smooth. And it's smooth all the way down. And then towards the end, when the sky crane maneuver starts, you will see a wheel that actually comes into view of the video, and you'll see all the dust being blown up by the jets on what I call the jetpack. So let's take a look at this one.
Thrusters have been re-enabled. We will control our attitude on shoot. We are decelerating. Rift mode under our technology is decelerating and descending. We are at 150 meters per second.
Dynamic
Risk mode is nominal. We're at 9 kilometers at descending. Please exit. Down range.
I don't know how they understand what's going on because there's so many people talking.
Fire the ground with the radar. Now to the 8 kilometers. Digital section has separated where we found the ground expand zones due to
that spot right
as
over there?
expected. We're standing by to prime the Emily engines in preparation for power play. We're down to 90 meters per second at an altitude of 6.5 kilometers descending.
See some of the craters.
Flight video, we've got video warnings. It has been battled towards low associate power director of communications at this time. We may have lost it already. We're down to 86 meters per second at an altitude of 4 kilometers and descending. We've lost tones from Earth at this time. This is expected. We're continuing on Odyssey telemetry.
They're referring to the Odyssey spacecraft that they
Ground
talked about.
elevation equals minus 10.8 meters, vertical velocity of minus 80. We are priming 8 meters per second. Start enabled, standing by for batch cell separation.
And here you're going to see the jerk.
Signal to Odyssey is still strong.
We are in powered flight.
So now it gets a little more smooth, and we're getting real close to the ground here.
We're at an altitude of 1 kilometer descending.
Watch for the wheel right up in here.
Signal to Odyssey remains
Down to 50 meters per second. 500 meters in altitude. Standing by for Skycrane. Constant velocity accordion nominal. Altitude error 5.9 meters. We found a nice flat place.
There goes the
We're
dust.
coming in ready for Skycrane. Down to 10 meters per second. 40 meters altitude.
There's the wheel.
Skycrane has started. Descending at about 175 meters per second as expected. Expecting final cut shortly.
Signal to Odyssey remains strong.
Tango down to nominal.
That means touchdown. Now notice there's no, you don't see any dust. You can just see pebbles on the ground.
UHF stable. UHF is good. Touchdown confirmed. We're safe.
So that's a pretty neat perspective of the landing. So if they want to use this technology again. Now, there's a couple of other spacecraft that are orbiting Mars. You have the Mars Reconnaissance Orbiter. You have the Mars Odyssey. There's also the Mars Express, which is a European Space Agency spacecraft, which is kind of a backup for us. But the Mars Reconnaissance Orbiter took some incredible pictures, and they had to do quite some interesting things. It took them several months to write the software so that they could capture some of these images, because they had to roll the camera, and they had to roll the cameras on the spacecraft a lot further than they're supposed to go. And so they had to do a lot of maneuvering. And also, this spacecraft was very low on the horizon, so it was amazing that it was able to capture. But that's a picture of this parachute after it was deployed, and you can see the spacecraft underneath it, which is pretty cool. And then this is an image also from MRO that shows where all the pieces landed. So you have Curiosity, which, by the way, they named the landing spot for Curiosity after the Bradbury Landing after Ray Bradbury. But you'll see how it's darker here from the jets.
Yeah, all the dust is blowing.
The heat shield is over here. You have the back shell and the parachute. And then the sky crane, that was the jetpack where it flew off to. They actually have some other images. I don't know if you saw in the video, but as it's coming through the atmosphere, they use pyros to pop off these ballasts that were just weights to try to reshift the center of gravity. And they actually have images of all 6 of those ballasts on the ground as well, which is amazing. Okay, so we're going to very quickly, I'm going to tell you a little bit about what's happened since the rover landed. The first thing they did was, for several days, a couple of weeks, All they did was they did health checks, they took some pictures, and they uploaded some new software. When they launched Curiosity, it just had the landing sequence software on board, and so they had to swap that software out for the actual mission software. On the 19th, it zapped the first rock called Coronation, and by the way, Curiosity is on Twitter, so you can follow the tweets. And when she zapped her first rock, her tweet was, "Pew, pew." This is pretty funny. On the 22nd, she had her very first drive, and I already told you they named the landing site Bradbury Landing. On August the 27th, they transmitted from the rover back to Earth the very first human voice from Mars. They had a pre-recorded message from Administrator Bolden, and so they received that back on Earth. On August the 28th, the next day, they had the very first song ever transmitted from another planet by will.i.am called Reach for the Stars. And they did a little documentary about it. You can also see that on the internet. And he got a bunch of kids involved to sing. And I don't know if you're familiar with will.i.am from the Black Eyed Peas, but he is a huge supporter of NASA. He's also a big sponsor of the first robotics. And so he actually went to a like a science and math magnet high school in California. So he's very interested in science. Let me show you a couple of pictures. This is a picture of the rock that she zapped, and it showed, I don't know if you can see it, but you can see a little hole. Laser's going up. There's a little hole right there that she zapped with the laser. And then before she took her first drive, they tested all the wheels and the arm, and I called it the Hokey Pokey. So they stuck the arm out, pulled it back in, stuck the arm out, pulled it back in. They put the wheel out, put it back in, the wheel out. She did the Hokey Pokey. And then this is a picture that she took with the mast cam. Those were the eye cameras that were on the mast. And this is pretty far away, so it's an amazing picture, but it shows, this is the base of Mount Sharp, which is where she's heading. But look at all the striations in the rocks, and so they're very excited about seeing what that's all about. Those striations tell you the history of that material there. All right, in September, began doing some robotic arm work and some vibration testing. Now, one of the scary things about sending any spacecraft anywhere is worry about contamination. They do everything they can to try to clean it and to take all the precautions and testing and all that, but they still have to do some cleaning. And so the vibration testing on the scoop was just to make sure that they get any potential material from Earth out of the scoop, because that's the device that's going to put the rock samples into the instruments. They want to make sure that there's no Earth-made materials or Earth materials from Earth. September the 14th, they find an old stream bed. I'm going to show you pictures of that. And she touched her very first rock on the 22nd. So take a look at this picture. Both of those pictures look very similar, don't they? And what this is a stream bed. Actually, both of them are stream beds. One of them is from Earth, and one of them is from Mars. Which one do you think is from Mars?
One on the left.
One on the left, that's right, because it's red. See all that red? But see how similar it is to the one on Earth? Lots of interesting stuff. And then this picture on the left is the SAM instrument. Those are the inlet covers. That's where she takes the scoop and dumps the material down into. So it's just an animation that shows you the covers opening and closing. And then this is that first rock that she inspected. It's about a football-sized rock. In October, she arrived at an area called Rocknest, and she spent quite a bit of time there. On October the 3rd, she checked in on Foursquare. Has anybody ever checked in on Foursquare? It's a social media type thing where if you go to a restaurant or a museum or something, you can check in and you earn points and badges. And by the way, if you have Foursquare and you go to a science museum, anything that's designated in Foursquare as a science museum, you will get the Curiosity Rover badge, which is that little picture on the bottom right. And I have it. I went to the parole last month. So October the 7th, she did got her first scoop of material, and then they found a very bright object on the ground, and this was problematic because it did not look like it came from Mars. It turns out that it was a little piece of plastic, and they think it was some kind of a cover on a wire, something that may have dropped off of the rover during the violent landing procedure. They found another bright object later, but it turned out to be Mars, a Mars object. The first soil sample was delivered to the Kemin instrument on October the 17th. The picture on the left is a picture of the scoop and what it looks, the actual scoop in the ground. The one on the right is the soil that's in the scoop itself. Now, what happens is that they did extensive testing on this rover, and they determined that they would do a cleaning procedure 3 times, and that would guarantee that there would be no earth material left. And so she scoops up the material in the scoop, shakes it, and then dumps it out. And then she scoops up some more, shakes it, and then dumps it out. So she did that 3 times before she ever put any material into the instrument. November. At the very beginning of the month is when she took the self-portrait that I showed you at the beginning. November the 6th, they decided to switch back to Earth time. As I mentioned earlier, Mars day is about 40 minutes longer than ours, and so it was getting to the point where the JPL engineers were like working really late hours, and so they switched back to Earth time, and now they're kind of on an 8 to 8. I think they have 2 shifts that work. The SAM instrument was used for the first time. That's the sample analysis at Mars. That's one of the principal instruments. On November the 10th, monitoring of a Martian storm. And what was interesting is that you have opportunity. So if you have the Mars, opportunity is over here. Curiosity is over here. That dust storm was kind of in the middle. And both of the rovers were able to pick up see some environmental things going on with that dust storm, even though it was hundreds of miles away. On November the 26th, it had been 1 year since the launch, so I had a little celebration there. There's another picture of the self-portrait. It's actually a mosaic of 55 images that they stitched together from that camera that's on the robotic arm. And on the left, you can see the 5 scoops that she took, that she got. And then this is another instrument there. Oh, and I was going to point out, these little black and white discs, you see them all over the rover. Those are camera calibration targets that they used to make sure that the cameras are calibrated. Okay. Now we're on to December. Am I going too fast? Are y'all awake?
Mm-hmm.
Okay. All right, just check. Now, at the very end of November, does anybody listen to NPR? Okay. And I was listening this morning. John Gratzinger, who is like one of the big project managers for this mission, told NPR that they were going to make a big announcement at the American Geophysical Society meeting on December the 3rd, and that it was going to be earth-shattering. So, of course, for several days, everybody's on pins and needles. Okay, what is this announcement? What is this announcement? Well, they sort of backtracked right after that and said, we really meant, the whole mission is going to be earth-shaking. We just know that it's going to be, but we don't have anything really big to tell you right now. So, on December the 3rd, they did make an announcement of that first soil sample. They detected water, sulfur, chlorine-containing substances, and some other ingredients, but no organics. So that's what we thought the earth-shattering thing was, is that, oh my gosh, they found some kind of organics. But no. They thought they had detected a little bit of methane, but they determined that it probably came from Earth. On December the 4th, the very next day, they announced a new rover that will be going to Mars. I believe it's in 2020. And they are actually going to use some spare parts from Curiosity. And so they made that announcement. Yeah. On December the 11th, Curiosity arrived at an area called Yellowknife Bay, which is where she's at right now. And starting on December the 21st, she took a little holiday break at Grandma's house because they found this little area that looked like a river. And she was going to take a bunch of pictures like you do at Grandma's house. So through the river and what is it?
Over the river.
And yeah. So they named it Grandma's house. And just before the area called Yellowknife Bay is this area that they call Shaler. Very interesting geological things going on here. In January, everybody comes back from vacation and she continues driving in Yellowknife Bay, finds a snake-like rock formation called Snake River, and on January the 6th, she used her rock brush for the very first time. So not a lot going on in January. After she used the rock brush for the first time, pretty much the rest of January was just getting prepared to use the drill for the first time. So they do everything really slowly, and so that was pretty much all of January. Now this is the Snake River. If you see this little thing here, it looks like a snake. What's interesting about Yellowknife Bay and why they're spending a lot of time here is that the geology and all of the features are completely different than the landing site. And so they found some really interesting things they wanted to spend some time looking at. This is what when she used her rock brush for the very first time. The rock brush is made out of stainless steel, and they wanted to do a test to make sure that that stainless steel is not going to scratch the rocks. And so this was a little test that they did. Okay, now up to February. Lots going on in February. On February the 2nd, she did her first drill test, and what it was is she just touched the rock with the top of the bottom of the drill, and just kind of did a little test to see how it was going to work. And then on February the 8th, the very first drill of a rock performed on another planet occurred. On February the 20th, which was just a few days ago, they received confirmation that the powder from the drill actually made it into the scoop. If you remember that picture that I showed you, the rock powder goes up the drill and it goes through all this stuff and then ends up in the scoop. And they got pictures back from Curiosity that confirmed that it had made it there. And then on February the 22nd and 23rd, the rover delivered a little sample. Now these samples that Curiosity delivers to the instruments is about a baby aspirin. If you crushed a baby aspirin up, that's about how much that she drops down in there. So not very much. So she vibrates most of it out, gets all the big pieces out, and then takes what's left. At this point, she's not done any driving for quite a while, almost a couple of months, and the odometer is almost at the half-mile mark. And as of today, it is Sol 202. So she's been on Mars for 202 Martian days. And from now on, now that they've tested all of the instruments now. Once they did the drilling, that was the end of the testing of the instruments, and they are going to start driving her towards Mount Sharp. It's going to take about 9 months for her to get there. And they will stop along the way and look at some rocks and do some different things if they find anything interesting. This is a picture of the drill, a hole. The hole itself was about 2.5 inches deep and just a little over a 1/2 inch wide. So there's actually two holes there. Now, what do you notice about the powder that came out of that rock?
It's a different color.
It is a different color, which was a surprise. Sort of a surprise, I think. So they're going to be interested to see. It'll be probably a few weeks before we find out what the instruments told us about that. All right, this is a traverse map as of February the 21st, and you'll notice that around Sol 166 there isn't anything else, and that's because she's been pretty much in the same spot since day 166. There's Bradbury Landing. You can see all the stuff that the jets blew up. And this was the, shortly after the landing, probably about an hour or so. I don't know if any of you stayed up that late to watch this, but this was the first conference call that they had after the landing. And it was quite incredible. And their theme was kind of dare mighty things. And I kind of used the saying that last week at the Texas Astronomical Society meeting, we had Dr. Alan Stern, who is the principal investigator of the New Horizons mission that's going to Pluto. And he had something like 3 slides that said the same thing. It said only in America can we do this, and which is pretty incredible. So, I mean, I just think this whole mission is amazing. And I was telling somebody earlier that every time I watch the video of the landing, I have to get Kleenex out because it's really cool. Coming up at the end of this year is the targeted November of this year. It's the targeted launch date for the MAVEN mission, which is, I have to read this, the Mars Atmosphere and Volatile Evolution mission. And it will go to Mars, orbit around Mars, and study the upper atmosphere. So it'll be the first mission where they're going to study the upper atmosphere. And of course, if you've been watching the news, you saw this guy, Dennis Tito, is that his name? Tito. Privately funded round trip to Mars, takes about 500 days. And he says they're going to launch January of 2018. So anybody that's a middle-aged married couple, that's what he's looking for. And they were joking on CNN a couple of days ago that they thought they might need to send Dr. Phil with the married couple.
Or at least have radio check-ins.
Yeah.
Qualify as middle-aged by 2018?
No.
All right, so these are some of the websites, the Twitter account. There's actually a website that you can go to and drive the rover around. It's pretty fun. And again, these this photo that I have up here on the back has the websites on it. And but any questions? Yes?
What have they learned about Mars?
Not a whole lot yet. Because again, they have spent the 6 months or whatever it is testing all the systems. And so they have gotten some analysis back from the instruments, but they haven't found anything that's, you know, organics or anything exciting like that yet.
What do you think about that NPR announcement?
Well, one of two things. Either he just was really excited or they know something that we don't know. I think what it is, though, is that, again, when they first, I think they got a little ahead of themselves, because when they first got the analysis back from those first few samples back in October, they found methane, which is an organic material, and can only be produced by, you know, us and stuff. And so, I guess, so so I think they got a little overexcited. So, but then they kind of decided, you know what, that's probably
Methane may be an organic material, but there's an awful lot of it in space.
Yeah.
I mean,
Yeah. Anything else?
I heard about the married couple isn't actually going to be able to land there.
Right.
No, it's a
Or
flyby.
anything, so they got to travel how long to look at it?
501 days round trip with a 100-mile pass over Mars.
Do they get paid, or they
How
pay
many
like
miles
A
$100?
100-mile altitude pass over Mars. It's literally there and back. Yeah. It's something smaller than a Winnebago.
Yeah, that's
Something much smaller than one.
Yes.
yeah. It's gonna be small. Anything else? And I was going to mention, when they did the testing of the rover and that clean procedure, their requirements was that it couldn't have more than, was it 40 parts per billion contaminants that come from Earth. And so when they did the testing procedure, that was how they came up with the 3 scoops and dump before they did anything. That was, when they did their extensive testing, they found that that was what got rid of the Earth's mount. Yes?
There was one screw up on that though.
What was that?
The drill bit that was mounted in the drill. They were afraid that the drill would not be able to reach the magazine that held all the drill bits. So before the launch, still on the launch pad, they went ahead and mounted the drill bit. Not in the clean room. Oops.
Yes?
Tell me, what sort of information will this Twitter give me?
Well, of course, do you know anything about Twitter?
I'm not using it.
Okay. Twitter is a social media thing, and you have 140 characters to say something. Okay? So the way they do is they make it sound like it's really coming from curiosity, but there's somebody back at JPL that does all this stuff. And almost every, well, in fact, I'd say every NASA research center has a Twitter account. NASA is probably one of the most active social media users. They have Facebook, Twitter, Google. They do Google Plus Hangouts. I think they had one yesterday, as a matter of fact. So whenever there's a little news announcement, something that's new, they will, Curiosity will tweet about it and usually put a link. So it'll be a link to a new photo that's come back, a new video that's come back, or a news release that will usually take you to the NASA website. Yep. And of course, sometimes, you know, she'll just say funny things like the pew 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 when she did the laser with her.
I remember seeing that one on Twitter. That was cute.
Yeah. So whoever does it they're really good. Any other questions? So I think it's a fantastic mission already. I mean, they really haven't done a lot of science yet, but I think it's gonna be a great mission. Okay. And of course, I want to tell you a little bit about the Texas Astronomical Society, which I'm a member of. You can go to our website at texasastro.org. You've probably seen this 100 times if you've been here before, but if you go to the calendar up at the top of the page, you can find out about all of our events, which are always free and open to the public. We have our monthly meeting on the 4th Friday of the month at UTD. And if you missed it, we had a fantastic speaker last Friday. Really, really good. And then of course our weekly star parties. First Saturday is the Star Geezer Star Party in Garland at Spring Park. Second Saturday is Starfest at Frisco Commons Park, which is a really nice park. Third Saturday is the Star Bolt at the J.W. Williams Park in Cedar Hill. And fourth Saturday is Joe's Stars on the Rock in Rockwall. And you can get, if you go to the calendar, you can get more information about a map, how to get there, and all that information. And if, usually we will have, you know, if the weather's not good, we won't have it, but we have these pretty much every week. If there's a fifth Saturday, we don't have anything. So, and of course we have lots of other things going on too, like the Farmers Branch Historical Park, which is a really nice park. We do, in the spring and in the fall, we have star parties there. We have one coming up, what is it, March the 12th? No, the 19th, I think. And with the backup date on the 21st. And again, these are all free, so if you want to learn about telescopes or just to learn more about the night sky, it's a great place to go. Every week, in association with the Dallas Amateur Radio Club, at 9 o'clock on Saturdays, from 9 till about 10:30, we have what is called Skynet. Did I do it just like Tom does?
Pretty close.
Okay, all right. And if you're a ham radio operator, the repeater information is the Dallas repeater, the 146.88. Or if you're far away like me, I live out in the boonies, so I have to go on Echolink, which is a computer software that will let you check in there if you're a ham radio operator. If you're not a ham radio operator, you can go to Ustream, and watch a video and listen to the audio of it. We talk about astronomy, we talk about what's up in the sky for the week, we talk about International Space Station flyovers, and I do a report every week on Curiosity as well as NASA in general. And what else? We talk about news, all kinds of stuff.
Anything relating to astronomy.
So it's a pretty neat deal every Saturday night.
And single malt scotch.
And and actually I'm leaving to go to Lubbock very early in the morning, so I will be participating via Echolink tomorrow night.
From Lubbock.
From Lubbock. The amazing amateur radio. Okay, and let's see. And then I'll just leave you with this. This is another self-portrait image of Curiosity. Did you learn anything? Yeah.
Oh, yeah.
Okay.
Very good.